Next is Leonard, giving a talk Only You Can Prevent Data Fires, Getting Proactive About Data Quality. Sev is a technologist, educator, and musician with a focus on data platforms and jazz. So take it away, Seb.
Thank you. Hi. Hello. Thank you for coming to my talk. I hope you can hear me okay. All right. So in this talk, I'm going to talk about a couple of different things. The first one I'm going to talk about is an unfortunate reality in our region, which is the growing risk of forest fire and ways that you can protect yourself. We saw a talk starting off the conference this morning about maps. Here's a particular map called InsaWeb, which is a resource you can look at to find out about forest fires in your area and the status thereof. And then most of the talk is going to be about data quality, which is going to be drawing heavily on this book that I wrote, Cost-Effective Data Pipelines. And I'm going to be kind of covering things at a pretty high level. So in the backup slides, I've included a lot of links for you to read more as is relevant to your particular situation. Actually, these slides are already posted on my GitHub, and I'll provide a link to that at the end of the presentation. Okay, so let's get started here. We have this delightful little cabin. It has these trees. They're majestic Douglas firs. And it is made of wood, log cabin. It's very cozy, also very combustible. And so when you're thinking about forest fire risk, there's a couple of things you can do. The first thing is thinking about preventative measures. So these include things like defensible space. So the idea behind defensible space is that you clear a perimeter around your home of any fuel that fire could use. So you're essentially creating like a break for the fire. Another thing that you can do is use fire-resistant building materials. So perhaps instead of a log cabin, you would consider something like fiber cement siding that's very fire-resistant, or a metal roof. You can also get your gutters sealed, so rain comes in, but embers from nearby fires do not. And so you've taken some preventative measures. There's also kind of aspects of wildfire preparedness that you can monitor to know what the situation is where you're at. So there's a couple of different wildfire links I have here. There's a British Columbia wildfire map and InsaWeb, which was the screenshot I showed in the first slide. And this is really nice in case you're like maybe near an area where there's a fire, but you're not actively in it. You can kind of see, well, I'm gonna go for a hike or some kind of a trip. I wanna know if there's an active wildfire and what the status is. So that's a good way to help keep yourself safe. Another thing is purple air, which can help you assess like the air quality risk and help you to know that you need to take maybe preventative measures like wearing a mask outside if you're sensitive to that. And then finally, there's an aspect of this that is alerting. So you've kind of monitored the situation. You can sign up for various alerting platforms. So these are for Oregon, Washington, and British Columbia, that in some of these cases it's an app, and some of them it's like you sign up your phone number for public alerts, and you'll actually get an alert that says, hey, you need to get ready to evacuate. So these are kind of the three steps. You want to take preventative measures, you want to monitor the situation, and you want to know when you need to go. So when I think about data quality, I can see a lot of similarities here. So let's talk about what I'm calling data fires. So this is like a pipeline. You're getting some data from somewhere, you're doing some stuff to it, and then you put it someplace else. So let's say you have some questionable data that shows up in your data source, and it somehow breaks the code in your pipeline and causes a failure. Another thing that can happen is you make a code change and you check it in, and maybe it doesn't break anything, but maybe it breaks the transformation logic in a way that actually creates data you don't want in your data target. And then kind of the last type of issue that I want to talk about in this presentation is issues interacting with resources. So you're trying to maybe write to a database or call from an API, and maybe there's a contention issue or there's a temporary issue with getting to an API and you don't have like an automated retry mechanism, then your pipeline can fail, and that can impact the timeliness and freshness of your data. So when I think about how this relates back to the wildfire scenario, here's some preventative measures you can take. So we're going to try and get rid of those combustible materials. So one of those combustible materials here is bad or unexpected data. So introducing data validation into your pipeline can help you address that. And then, of course, another combustible material is code bugs, which you can catch with automated unit testing. And similar to defensible building practices, there are also defensible pipeline design techniques you can do to try and self-heal from known intermittent errors. In particular, I'll be talking about adding retries to your pipelines in this presentation. Okay, and then on the monitoring side, you want to be looking at your data quality, so monitoring data at rest to see what's going on, as well as monitoring pipeline operation, and this is going to give you kind of a sense of how the system is doing. And from there, kind of developing what your baseline expectations are around data quality and pipeline operation, and deciding what your known good range is, and figuring out, okay, above what thresholds do we need to say, okay, things are on fire and somebody really needs to take a look at this. So what I'm really trying to drive home here is that data quality is not one thing that you're doing in your data processing systems. It's really a very system-wide endeavor that covers all of these areas. And so this is a lot of information. For this talk, I'm just going to be focusing on the preventative measures. Okay, so we'll start out with data validation. And before I even sit down and look at the data framework that I'm using to see what kind of data validation measures it supports, I try to ask myself the question of, given what I know about my data sources, what I know about the code base, what I know about how this data is being used, are there any kind of structural changes in the data that could either cause a pipeline failure or degrade my data quality? And I like to do that because I feel like once I get into the frameworks and I see things like, oh, great, they have null checks, or they're going to allow me to check expected values, my mind sort of goes to those things explicitly, and I kind of forget about whatever else I was thinking about. And a lot of times you can also build your own custom data validation. So I'd suggest you start here. So here's just kind of a little bit of an example using JSON schema. So what I have here is a very basic schema. There's one attribute in our schema, the description field. It's a string type, and it is identified as a required field. So then I can use this schema to check various types of data that come through. So here I'm validating, this is an empty object, but it says, I have a validation error, description's a required property, and it's not there. And another thing that will happen is if I specify description, and let's say it's a number, it's not a string, it's going to say, hey, this isn't a string type. So a couple things about this. Number one is a schema. Schemas are awesome. They're a really great way to describe what you're expecting from data or what you're going to provide to other people. They can also be part of a data contract in kind of a more formalized space, so I highly recommend using schemas. Another thing here is it's giving you the opportunity to actually catch the bad data, which is maybe a little bit obvious, but it's taking those kind of unknown things that can cause a fire and making it known to you. So maybe you want to handle this exception and do something, or maybe this is something you're like, yeah, if this exception happens, I want it to actually bubble up and fail things because something's really wrong and we need to stop. And then another great thing about this is I really love how descriptive the JSON schema validate log messages are. They tell you exactly what is going on. So when you're trying to debug what happened, you can go into your logs and see exactly what the validation failure was. So I'm going to highlight some data validation capabilities in some popular data tools just to give you an idea of what's out there. So the first one is when you're working with Spark. This is a PySpark example. You have this option when you're reading in some JSON files where you can specify this mode parameter. Mode, there it is. This is a new pointer. This is very exciting. So this permissive mode, what this means is you can see that this is kind of a corrupt file. So there's two records that have a location in a user field that were parsed correctly, but then there's actually a corrupt record for record number 3 where the JSON itself is incomplete. And by doing something like this mode, permissive, is one of a couple of different modes that are supported, but it's nice because you're kind of quarantining the bad data. You can still move forward with acting on the good data if that's what makes sense for your use case. And let's see, so if you're using Confluent Kafka, they have this really nice schema registry offering where you can say, okay, here are the acceptable schemas that I think are good for the data coming through the streaming pipeline. And if you see data that doesn't match a accepted schema, then you can say, map it to, or send it over to like a dead letter queue, which you could also use maybe in your monitoring. Like, for example, you expect to see a couple of defects coming through into your dead letter queue. But if that queue starts to accelerate the amount of data that, or the amount of records that are in it, that could be a sign that you have some schema drift in your source data or that a bug has occurred. Airflow also has some really nice capabilities here. They have these like SQL check operators where you kind of more in an ELT fashion. Let's say in this case you're reading out a snowflake. You can actually write validation constraints on either the table or the column level. And let's see, if you're in Databricks using Delta Live tables, they have this concept of expectations, where here it says expect or drop, and then the first parameter is the name of the constraint, and then it says ID is not null. So what's happening here is you're saying, I expect ID to be not null. If I encounter a record with a null ID, I'm just going to drop it and not put it on my table. And then DBT has a lot of really excellent testing resources available for you. This is a simple example of what's called a data test, where you're identifying this is my data source, this is the table, and for this description field, I'm going to say this should not be null. So just at a high level, here's some examples of how you can do data validation with common tools. So now to kind of move on to the next kind of defensible space thing, we're going to try and eliminate or reduce as much as possible bugs coming in from our code base, and doing that with automated unit testing. And kind of the automation here is the key, where you want this to be running when you check in your code, so before anything gets deployed, you're able to catch bugs. What I have most often seen as common automation barriers are kind of fall into two categories. One is how code is structured can make it very hard to test in a unit test. And the other thing is maintaining test data. Because data changes a lot, it can be very hard to keep test data up to date, or in some cases it's actually not really possible because data changes so frequently to model it well. In this talk, I'm going to be mostly focusing entirely on the code structure piece. So let's look at some examples. So here I have a Spark data frame. This is a pretty typical like analytical process. You're going to like read some data, you're going to create some columns that are doing some functions on the data, and then you basically are performing like some kind of an aggregation, right? So there's a lot of benefits with code that's structured this way. First of all, it's super readable. You know exactly what's going on. It's all in one place. It's very easy to change if you need to change the aggregation or you need to add more like pre-processing steps to it. You can just add this inline. And so the unit testing for this would involve, you have to create a source file because it's reading from someplace. You also have to then read the result file because this includes the write piece. So it will read the source, do the stuff, and then write it out. So you kind of have to read in this result file and then in your test compare that to expected results. The other thing about this is a little bit hard for me to describe. It's like the thorough testing of this is kind of difficult because you're effectively trying to test both the pre-processing logic and the aggregation at the same time. So that can make for some complicated test suites. And then as it relates to code changes, ideally you want to sort of limit what code is potentially touched when you need to modify something. And here it's pretty much all of the code here will be open to modification if you have to make a change to just the pre-processing or just the aggregation or adding a new function altogether. So a way you can consider structuring this code that's a little bit more amenable to automated unit testing is to break it down into functions like this. So what I've done here is I now have the pre-processing steps in its own method, and then aggregate is a separate method as well. So the benefits of this is, number one, when you're testing, there's no files to manage. You can just create test data frames in memory as part of your test suite, and you don't have to deal with being able to read and write files in your CI/CD pipeline. The other thing is, because you'll notice the parameters of these methods are data frames, and they return a data frame, you retain the ability to chain. So you can still create kind of like a chained data frame operation. It is not, I would say it's not as readable as the other version that I showed first, so that's a drawback. And then the unit testing for this, as I mentioned, it's basically you're going to be just working with data frames, so only working with memory. And then you can also test these functions independently. So as I mentioned, it can get a little bit hairy to test a really long data manipulation function because of all the different test cases you need to kind of merge together. In this case, you can test both of these things independently. And another advantage is the changes are really isolated. So if you need to add or change pre-processing steps, you're just touching one of these functions and not the other. So kind of similarly, this is an example of an Airflow DAG where I've got a good DAG, that's my DAG, and I have two tasks. That one is I'm going to get some configurations, which I've put this in comments here, but just imagine it's actually code. So it needs to query an API from which it's going to get some kind of customer configurations, and then it's going to map it to this configs object, which is then used by the second task to do some data stuff. So it's going to perform some operations on the data. And so the idea here would be all of the logic is contained at this DAG level, which can be difficult to test unless you're going to actually run the whole DAG. So a recommended way to do this instead is to actually factor out your logic into a module. So you can then use this DAG tasks module, import the code that you need here in the DAG level, but then you can use PyTest and test the functions in that module just kind of as you would any other Python code. And this technique is also a good one to consider if you're using notebooks, is kind of taking that code and abstracting it into a Python module for automated unit testing. Okay, and then the last thing I wanted to talk about was this idea of defensive design. So kind of like you would use fiber cement siding or a metal roof, what are some things you can do in your pipelines to sort of shore up the way that they operate? And so the idea here is to think about ways that you can have a data processing system self-heal from intermittent issues. And intermittent is the key here because you're basically building in some time to say, oh, we tried to hit that API and we got an error we think is going to clear up in a little bit, and we're going to hit it again. So I kind of think about retries in three different levels. One is at a low level when you're interacting with a resource like a database or an API, or maybe even like cloud storage is one I've done before as well. The next level up is kind of a task level, so you could think of it as an Airflow task or like whatever your data processing framework is. And so at that higher level, you might be doing something like, we're going to retry from a data checkpoint, or maybe there's a low-level retry that timed out its first couple attempts, but you're like, we want to give it another little bit of time to come back online, and so you can also do that at this task level. And then at the pipeline, retrying kind of at a pipeline level is still kind of a longer time period yet. So one example of where I've used pipeline retries is I was working with an API that had a call limit that literally was like 100 calls per day, and we needed to call the API potentially more than that. So when we hit that limit, we had to reschedule the pipeline to literally start running the next day. So this is kind of longer term retry mechanisms that you would use at the pipeline level. So to kind of walk through an example of this, so this task is sending emails. So a pipeline that I've worked on before computed a bunch of data for customers and then would send them an email and say, hey, your data is ready to take a look at. So here I'm illustrating kind of two levels of retry. So I'm using the Tenacity library to do kind of the low-level retry where I'm making a request to put that the customer email body to the endpoint. And so some things to note about this. Number one, I'm specifying when I want to retry. So I'm not retrying all the time. I only want to retry on something I think is recoverable. I'm then telling it, I have this exponential backoff, so it's good to, not just retry at the same interval. You may even want to add jitter if you have kind of multiple threads running to keep from bombarding that resource simultaneously and keep having, like if you have a contention issue, for example. And another thing I really like about Tenacity is like this line, like before sleep log, this will actually log like, hey, I'm making another attempt, I'm making another attempt. So if you keep seeing these kinds of timeout problems, you can actually look through your logs and see how many times something was tried. And then, so at the low level for send cust email, that's going to retry a couple of times. And then at the bottom here in line 13, this is an Airflow task which has its own retry, which you can see this is going to retry after 20 minutes and then after 20 minutes again. Now, the benefit of kind of splitting it apart like this is for the airflow task, because it's going to retry it instead of just blocking and waiting for like 20 minutes to see if like this task comes back or this API response clears up, it's going to allow you to put that task back on the scheduler and free up that worker slot so other airflow tasks can move forward while this one is waiting. So they can be a really advantageous unblocking mechanism. Okay, so I've talked about a couple of different ways to try and prevent data fires, but it really is a very custom effort based on the specifics of your scenario. So for instance, I would love to live in the forest. I think that sounds great, but I don't. I live in a city. So I'm probably not going to go and cut the tree in my backyard down as a way to create defensible space around my home because that doesn't relate to me. I will, however, check purple air when there are forest fires so I know if I shouldn't go outside or if I need to wear a mask. So that's kind of my custom plan there. And so I try to think about how do you come up with this custom plan of what to do? And so for me, it usually starts with, over here, what could go wrong? And I'm really good at thinking about what could go wrong, which is why you want to temper it with other things. Like, how likely is it that something's going to go wrong, this thing that you're considering? And then also, what is the effort or even the feasibility of trying to fix the problem that you're worried about occurring? And then lastly, what is the impact? If this problem does occur and you aren't able to fix it, what is the impact to like your users or your product or your system? And so I wanted to walk through two different data quality plans for systems that I've worked on to kind of illustrate this concept. So the first data quality plan is for a clinical trials data platform that I worked on. And so the aim of this platform was to come up with treatment options for patients. Okay, so this is pretty important for data quality. The impact of poor data quality is that it degrades patient care. So again, that's a pretty big deal. So some of the system considerations, this is a pretty small data set. So there's going to be some manual processes in here that are tractable because it's small data. And this kind of the system that we're running was Postgres in an ELT fashion where we would load the data into a staging table and then we had SQL stored procedures acting on the data. So what was the data quality plan for this? Okay. So the first thing is we did do data validation, very thorough and very strict data validation on things like the physicians we were working with were targeting particular like immunotherapies that they wanted to look at. So if we got patient records that did not have the expected values in the immunotherapies list, we would discard them because they weren't relevant to these clinical trials. And also certainly null checks. If we get a record and it has a missing medical record number, we don't know what to do with that because it's not associated to a patient. Another thing we did, as I kind of mentioned or alluded to, is this manual adjudication of bad records. So we had a data steward who would look through the records that we were unable to process to make sure it wasn't like, well, we rejected this. We rejected these records because we didn't recognize this immunotherapy, but maybe that's because there's a new one, and what we need to do is go and talk to the physicians and say, hey, we're seeing this new immunotherapy in our records. Should we include this for the clinical trial? And they may say yes or no. And then we did have automated unit testing here. And yeah, as I mentioned, so we did have that kind of manual data quality review. And so kind of to contrast, here's a data quality plan for like a very early stage cybersecurity startup that I worked at. So the point of this platform was to sort of filter cyber threats down to what was just relevant for a customer. If the data quality was bad, that's not ideal. Like you're telling them like, hey, maybe you're exposed to some threats that you aren't. But the people adopting the platform at that time were very early. They were friendly. They understood, that we could have some bugs, but they were like, look, if you take down the universe of potential threats from like 100,000 threats to even like 100, and some of them are not right, that still is a huge win for us. So that was okay. And the system considerations for this, large scale data, so manual checks are hard. We had a lot of data coming in from different APIs, so that data could change unexpectedly. Python SQL Airflow was the stack for that. And so here's a data quality plan. So we did do data validation, but only on internal APIs, and we had a schema match that we would do similar to the one that I showed with JSON schema, because there were simply too many APIs for us to try and model. It didn't make sense for us. There were some automated unit tests, but again, because of the data situation, mostly we relied on integration testing to test our data, or our data processing stuff, and sometimes bugs slipped through, and we had to deal with that. We did have automated retries, because again, this is a system at scale, so the less, I think we had about 1,000 DAGs, so the less we have to worry about manually restarting our pipelines, the better. And yeah, I think that is it. So some last things. This is how to get a hold of me if you want to connect. Like I mentioned, my slides are in GitHub. This is the repository for my book that has a bunch of code examples. And let's see, this QR code is for California wildfire recovery if you want to be involved in that. This QR code is if you would like to check out my book for 30 days for free. If you have trouble redeeming that, please let me know. And okay, if you're visiting Portland Winter Light Festival is going on. You should definitely check that out. It's very cool. And finally, if you wanted to, you didn't get enough of me tooting my own horn during this presentation, I am playing my actual trumpet with the Rose City Pride swing band for a swing dance next weekend in the Columbia River Gorge. So yeah, that's all I had, and happy to talk to folks after this. Thank you.